discuss about the concept of Thevenin theorem. So first of all, what is Thevenin theorem? Using Thevenin theorem, we can convert any complex circuit to the Thevenin equivalent circuit. For example, this is a voltage source Vg, and consider the one complex circuit here. This is R1, this is R2, this is R3, and this is known as load resistance, because according to two-port network we consider here the two port, one is input and this is output. So here input is 1 dash, named as 1 dash, and output is named as 2 dash. These are equivalent to two-port circuit, and this is a ground. So according to Thevenin equivalent circuit, after convert using Thevenin theorem, the circuit is look like that. This voltage source is converted to Thevenin voltage source, and all resistance are converted to the Thevenin equivalent resistance, and here connected the load resistance RL. And after convert this Thevenin equivalent circuit, we measure the load current IL. So what is the value of IL? So here IL equals to, this is a very simple equation, VTH divided by RTH plus RL, RTH plus RL. RL here means load resistance. So how we convert this complex circuit to this simple Thevenin equivalent circuit? So there are some basic steps are required. At the first step, we measure RTH, and the second step we measure VTH. For RTH measurement, some rules are followed. The rules is for RTH measurement, at first Vg equal to 0 or short circuited. That means in the circuit all voltage source or all DC voltage sources are short circuited at first, and then load is infinity, that is load is open circuited, and we measure RTH from this load section, and we measure this RTH value from the load terminal. This is the first step. In the second step, we measure the VTH. What is the process to measure the VTH? To measure the VTH voltage or Thevenin equivalent voltage, at first open circuited the load terminal, and then measure the open circuit voltage across the load terminal. This open circuit voltage is also known as Thevenin equivalent voltage of this circuit. Okay, so there are the two steps are required. So now at first we measure the RTH. How we calculate the RTH? So if we convert this circuit to RTH equivalent circuit, so at first this DC source is short circuited, 3 resistors are connected, named as R1, R2, R3, and here from this terminal, open circuit load terminal, we measure the Thevenin resistance. So what is the Thevenin resistance? The Thevenin resistance is, we measure the resistance from here, so we evaluate this value from this side. So at first R1, R2 are in parallel combination. So R1, R2 are in parallel combination with series with the resistance R3. This is resistance R2. Okay, this is the value of resistance R2. Is R2 resistance. So this is the value of Thevenin resistance of this circuit. So R1 R2 in parallel combination with the series combination with R3. So this is the Thevenin equivalent circuit, and to measure the Thevenin resistance. So now we calculate the Thevenin voltage. So what we gonna do? At first, presence of this DC voltage source, draw this circuit again and just open circuit at the load terminal. Here the three resistance R1, R2 and R3, and we measure open circuit voltage from here. So what is open circuit voltage? Here see that the current is only flows from this circuit. Here this resistance is open circuit, that is here current equal to 0. Okay, so what is the value of current of in this loop? In this loop the value of current equal to, applying normal simple KVL law, R1 plus R2. Okay, so this is the value of current I. Why? Because this is a DC voltage source VG and the total series resistance equal to R1 plus R2, because the current across R3 equal to 0. Okay, so now what is open circuit voltage? So here current equal to 0, that means the voltage drop across this resistance equal to 0. So open circuit voltage equals to current into this resistance R2. So across this R2 voltage is equal to the, or the voltage across the R2 is equal to the open circuit voltage. So just putting here the value of I, that means VG into R2 divided by R1 plus R2. So this is a Thevenin equivalent voltage or open circuit voltage. This open circuit voltage is also known as Thevenin equivalent voltage. Okay, so step 1 and step 2 are done here. Now finally we draw this circuit. This is VTH, this is RTH, and this is RL. This is RL, this is RTH. So finally we calculate the load current. So what is the value of load current? As previously said, load current equals to VTH divided by RTH plus RL. So just putting here these two values of VTH and RTH, we get the value of IL for this circuit. Okay, so this complex circuit is converted to this simple, the equivalent circuit, Thevenin equivalent circuit, or this simple circuit. So that's why we need the Thevenin equivalent circuit or Thevenin equivalent network, and that's why Thevenin introduced the new concept. How can we convert this complex circuit to a simple circuit for measure the load current? Because this circuit is very complex. Because using mesh analysis or without Thevenin theorem, we can analysis of the circuit, but here flows two current, I1 and I2. If we apply mesh analysis process, and after some KVL equations, we can get I1 and I2 using matrix method. So this is a very complicated method to measure the load current. Load current means this current. This IL equals to I2 also. I just mention the different name. So what is the advantage of this Thevenin theorem? The advantage is that this complex circuit, or without any complex matrix equation, we can convert this circuit, we can convert this circuit into Thevenin equivalent circuit and measure the IL directly from this circuit. So this is the advantage of Thevenin theorem. Okay, so two parameters here, two parameters are noted. One is RTH and another is VTS. These two parameters are very important for Thevenin equivalent network.